So I want to welcome all of you to the HNR seminar series. This is the fifth and final talk of the series. The series is a revived version of a series that existed a few years ago, and I hope it'll become a tradition, become a norm to have this seminar series that brings amazing talks about networks and usage of networks in historical research. And I want to thank, before I introduce Malte Vogl, I want to thank all of you for coming and all the speakers that spoke until now, including Malte, for coming, talking, introducing their work and their ideas and their methodologies. And one other thing, I'll also say it at the end, the talks are also available later um, on our YouTube channel. And I hope you all come to Turin to the HNR conference during the summer and to our other conferences. So I want to introduce Malte Vogl, who works faculty member at the Max Planck Institute for Geoanthropology in Jena. And he's going to give a talk that sounds amazing about networks of collaboration and interdisciplinarity in scientific institutions, which is about the Max Planck Institutes and history. So, Malte, the floor is yours.
Yeah, thank you very much. I'm really happy to be here today, and it's a very kind of curious presentation to give because on the one hand it's a very old project, but during the preparation to this for this talk, I started to get interested again in it. So now I'm actually actively pursuing it again. So that's the life and death of science. Yeah. But I want to talk about networks of collaboration and interdisciplinarity in scientific institutions. And I will um, introduce to you the motivation of this whole research project, where it came from. And I wanted to also give you the chance to comment on the talk and ask questions asynchronously. So we have a shared pad that you could use if you want, where we can have a, so to say, a discussion afterwards as well. And the slides are available on Zenodo already. So structure is first that I will motivate where the whole idea came from and where we then what methods we started using for this idea. That's the topic of knowledge networks. Then, if time permits, I will give you like a short interlude on how it ideally would look like, this type of knowledge networks, but that we have to see how time is enough. Then I will talk about the challenges that come with such methods if we want to do something like big data history. Introduce then the two approaches, which is one on collaboration and one on interdisciplinarity. And again, hopefully, if time is enough, I will tell you a bit about an ongoing research project, a really ongoing new research project on the history of fusion research. Okay, so let's start with the historical background of historical network research in my case. So the idea started in a project on the history of the Max Planck Society. So the idea was to look at the history of this science organization from its founding in 1948 until 2002, when a new president got elected. And this project was really a massive, in that sense, big history project. We had like 50 researchers, multiple perspectives like gender history, social history, but also history of science. And one big aspect of this project was digitization, because the archive sources were not yet digital at that point, because the project started in 2014. And I started as a research software engineer in that project, but then later got funding for my own, as a PI for my own project on networks and, so to say, knowledge networks, and then developed methods in parallel to this historical project. So this is where the idea came from. The Max Planck Society shortly is a really big organization. So, as I said, already founded in 1948, successor of the Kaiser Wilhelm Society. So, like already that's long-running history. We are state funded, so we have a lot of money in that sense. A lot of institutes, like historically more than 100, 25,000 people, 2 billion euros budget. And we have this self-organizing structure that will become a bit important later on, where we have internally organized ourselves into three sections. So we have the physics, chemistry, and technological section, the social sciences and humanities section, and the biological medical section. And the map that you see here is displaying the move of Max Planck Institutes in the course of the German reunification, how institutes moved to in the so-called Aufbau, so to extension east at that time. In that project, one large component was the aspect of putting everything digital. So we had to digitize 7,500 records of the central administration so that they were not yet part of the archive, plus 34,000 records of the already in the archive. So a lot of pages, 10 million roughly, half a petabyte of raw data on tape in the long-term storage. And as part of this research, to be made possible, actually, this type of big historical research, we had to also build a research data infrastructure. So we had large curated databases for, of course, all the archival sources, the people involved in running these institutes, commissions that are self-organized in the sense of what future scientific directions should the Max Planck Society pursue, and so on. And in the course of, for example, what you see here is then institutional co-institutional network. So if we have a director who is also in a university, we create a link between two institutions, and we can do that for all the different sections and see like patterns of, let's say, reproduction emerge that are different, distinctly different between different sections of the Max Planck Society, for example. We also created, in the end of the project, a knowledge graph as a proof of concept how, so to say, long-term preservation of such a research project could be possible. But sadly, we are not able to publish it publicly because it could contain privacy-sensitive data in the sense of, for example, we know that someone was considered in a commission as a new director for an institute, but then didn't become the director, so that information could be protected, so we can't easily share it with you. But it was a very interesting side project at the time. So so to say in the running time of the project, one, so to say, friction that always emerged between my perspective as a research software engineer and digital humanist and the classical historians was this, so to say, are we really part of the project, or are we just like helping them to do their research? And our kind of structural view was very much in contrast with their kind of micro history view. Not we came into talking, but it was a theme that of course popped up every now and then. And this, so to say, the idea at that time was mostly that can we find support for the existing classical historical research with the data-driven methods, or would we find actually contradictions? And one of these contradictions that you can see here in the plot is that if we want to do big historical data, we have to consider the biases of that data sets, and I will talk about it a bit later more. But what you see here is the content that, to be expected in publication sources in relation to the different sections. On the right is the social sciences and humanities section. And that's just the fact that we, as humanists, we cite differently, so it's not so easily digested in the big repositories. So we don't find the sources directly. So it's a common problem, and this is just, so to say, showing it, making it clear. Now, all of that is, of course, the project is finished since 23, so we have a large synthesis volume published. We are publishing a lot of still ongoing monographies of specific topics. That's not the topic today, but I want to address the point of how we in the ModelZen project then try to approach this type of organizational scientific history. And that is what brings me to knowledge networks. The oops. if we talk about knowledge, we first have to acknowledge that there are, of course, different kinds of knowledge, and they are actually not as displayed here decoupled. So any type of knowledge is, of course, personal, and so we can, in principle, differentiate between intuitive knowledge in the sense of the stuff that my kids, when they are born, will learn just by being on the same planet. So learning to walk, learning to breathe, stuff like that. Or if you have kids, like the observation that they always try to let things fall and test local gravity, and they do it every day and not only once, like testing gravity is still working, great. Practical knowledge is knowledge that has to be shared in person with an object in the sense of, for example, stonemasons that in antiquity builds sundials. So you wouldn't get a book and saying like, this is how you build a sundial in Greece 0 BC. No, you learn it. You have to actually take the sizzle and chip on the stone, and that's the way the knowledge, the practical knowledge, is transmitted. And you can also, of course, see that in the beginning of early modern times, in shipbuilding, in military workshops. There's a lot of knowledge that is not yet encoded in theoretical knowledge, but it is still knowledge. But what I want to focus, and what I, in principle, can focus on with this type of methods that I will present only, is theoretical knowledge. And with theoretical knowledge, we mean knowledge that can be expressed in science system and thereby also has a different transmission options. So I can have a book and I write it today, it gets printed tomorrow, and then it stays for 100 years in the library, and someone else will pick it up, and thereby I have this completely different type of knowledge distribution possible. So and that is what I have to focus on, because the sources that I want to work on with are printed materials, so stuff that is in the archive, in my case. So I will focus on theoretical knowledge. But to describe the evolution of theoretical knowledge, we use a concept called socio-epistemic networks. And the idea is simply that knowledge is not something abstract that can be purely looked at, but it's actually something that is carried by people, that is embedded in material structures, and also the semantics of the knowledge are not, so to say, neutral. They have their own history. And in the institute for geoanthropology, what, so to say, the additional layer that then got into my perspective is the aspect that we also have to think about the environment having an influence in what we can actually know. And if you think about this from a perspective of networks, then this is in principle a longitudinal multilayer network, so a very complex beast. And I want to try to give you an impression of what the different layers of this multilayer network could look like. But I also need to talk about another, so to say, level of abstraction in the sense of what methods do we actually use to look at this multilayer network. And if you think about one, so to say, science organization funding a certain type of research, that could be seen as a micro level history in this network picture. So we have a new funding instrument and we look at the effect that this funding has on a certain field. On the other hand, we can take everything that has ever been written on all sciences in a big citation base, for example. That would be the macro level analysis of science, saying like, what structures do I see? How statistical what statistical relations do I find, and so on. And both of these are very common, but actually the meso level is less common, and I think that's what's the most challenging. And by meso, I would mean that I want to be able to create macro level structures based on my micro level assumptions that I have established by doing micro level research. And we have tried to address this with agent-based modeling. I will not be able to talk about this at all, but maybe we find another venue to give you more information about this. Now, back to socio-epistemic networks. So in that multi-layer picture, I would talk about the relations of social entities. That would then be the social layer. So we have co-authorship relations, people being at the same location in the same conference, like you traveling to HNR conferences. I will be able to scrape us having attended the same conference, so that could establish a social edge, so to say. And for analyzing such structures, we can of course use methods from sociology, so social network theory and so on. If we think about the material layer, I talk about material representations of knowledge. So a publication is such a representation, but this caliper you see here is in principle also a representation of a material representation, because a lot of knowledge has been forged into one instrument. And by using that instrument, I'm actually creating a link to that knowledge atom, so to say. And we can use methods from scientometrics and science of sciences and so on. The semantic layer is the most challenging layer, in my opinion, because we would like to be able to create relations between, say, elements of representation of knowledge, but it's much less clear what is a useful representation in that sense. So is it keywords? Is it topics? Do we have to take like more complex entities like mental models? And we have a diverse set of fields that we could get inspired on from, like linguistics, psychology, computational neuroscience, and so on. And the image that you see here is one try of looking at one specific semantic debate between the fields that at the time thought that it is worth to measure gravitational waves versus that it's not good to try to measure them. Because the discussion was, do they carry energy or not? Can we actually detect anything? And this is, so to say, the complex map that tries to map the mental models behind that discussion. And it's only happening in 20 papers, but it gets already very complex. So that's so far we have actually said this is not automatable easily. So we try not to. We have to do it with close reading approaches in this aspect. From the environmental perspective, so how is the environmental layer influencing the idea, so to say, how knowledge can spread? There we have more recently looked at with people that was work from people in the Potsdam Institute for Climate Mitigation Research in the group of Jonathan Donges, and they have developed this Copan Core, again like a network framework. And the idea is that, for example, the way you you build infrastructure influences how you behave and thereby influences how you think. And they are very much looking, of course, on methods from system science and complexity science to address this complex aspect of knowledge evolution. So if you want to read a bit more about social epistemic networks, this is the source that we have published in the yearbook for History of Intellectual Culture. And as I said earlier, the slides are on Zenodo, so you will be able to access all of the sources later on as well. I think I have a bit of time to just give you a brief interlude. The idea is, how would we ideally construct such knowledge networks? And the purpose of this is to give you an idea of, so to say, the biases that you have to keep in mind if you want to try to follow this route of thinking. And of course, the main question is, how do we actually operationalize the idea of a knowledge system? And this is the knowledge system that you see here is by Gaston Lagaffe, who created a new library sorting as a labyrinth. And I just like bande dessinée. So if you think about history of science, what we normally do is we have an idea of what we want to look at. So we start collecting sources. And if you, like me, want to try to do digital history, digital humanities, you would then convert your type of sources into data. So that could be like a list of letters of Goethe, that could be all the papers of Galilei, that could be like all the printed books on a certain subject in a certain time. But of course, the data set is not yet any knowledge system. So to have a knowledge system, we also need to think about the ontology. So how are things in my data actually related to each other? So what can be in the data and how, so to say, what is outside of the data set. And at that point, again, we have to be aware that even creating an ontology is actually a research question-driven enterprise. And we need to take fair and care principles into account for this, of course. And if we have a network, like a knowledge system, we don't have networks yet. So networks are then, in this ideal picture, a query to the knowledge system. So I'm asking another question to my knowledge system. If you think about let's go back a step. On the lower left, you see like a list of physical review letters publications from 1959. So this is, you can create a database, like a knowledge graph from this. And then you would ask a question, who is citing similar sources in 1959, for example. So in that sense, you create the co-citation network as a question to the knowledge graph. And I wanted to make this clear because we have in the collection of the data a bias in the sense of what do I actually want to look at. In the creation of the knowledge graph, we have a bias in what do I allow in my knowledge system. And then we have the Sparkle query that is, so to say, the question to the knowledge graph, again, with a certain research question in mind. So we don't have neutral knowledge networks. All of them are, so to say, based on what we actually want to ask. And I think that's an important point because there are projects that try to bring everything together in one big knowledge graph, but actually that is, so to say, lowering, I think, the clarity of the idea. Okay, that's what I wanted to say. There are more open questions on this. So how should we actually, what type of knowledge systems can be knowledge by what ontologies? Are these projections, like the questions that we ask to the knowledge graph, actually generalizable? And of course, in my opinion, very interesting is, would we actually be able to say something about causal relations if we follow this approach? In the sense of what comes first. Is it like a social connection or a new semantic idea? That would be really interesting, but that is not the point of today. What I want to say today in relation to today is the challenges of big data history in general. And I'm, as a historian of science, or not really, but as a historian working on the history of science, I have to use this citation records, and there are lots of biases in them. So the coverage is really, really patchy. And we always have to remember that if you want to write something like a bit longer history for a certain thing. And one really interesting bias is, for example, here this map of the world according to Dimensions AI at the state of 2019. So there are a lot of white patches, and there's no one publishing any science in Central Africa, for example. That's just not true. And the same is true for language. So if you look at the lower left, that's actually the language distribution in the Springer Nature metadata, which was free at the time. And there's a lot of German in the beginning, of course, as a collection bias. But this shifts. And all of this is something that we have to take into account if we want to write big historical or pursue big historical science, let's say. Another important point is the accessibility of these sources. I had worked with dimensions because somehow they offered access, but if I do any science with this, I cannot enable a replication of this type of research. So it's a massive, it's a very performant access, but it's in that sense, in my opinion, useless for science because if it can't be reproduced. If you think about more recent sources like OpenAlex, it's open access, it's really nice, but it has a lot of data, and again, it's a sort of creating a sort of replication bias because I would need the big machines to do it. But I tried to address this. First, another challenge is if I'm not, so to say, the collector of my sources in the sense of I'm not creating the database, but I'm using a database. I have really a challenge with reproducibility because, of course, they work continuously on it. It's a business model, so they need to update their sources. So what is actually my archive state if I do like a query, run like write a paper based on this query, but of the backend, data backend has changed tremendously in the last in from, so to say, writing my paper to publishing my paper. And the one, so to say, the idea that I have or had for doing this work that I'm presenting today is that actually we have to create snapshots, and that is a challenge. So in the sense of I'm doing a snapshot, I'm putting it on Zenodo or somewhere else, and that is my state of the archive at point X. And so I'm basing my truth on that timestamp, so to say. But the problem is that we are talking about a few terabytes of data. And what I try to do is I try to solve this reproducibility problem for the case of OpenAlex by reducing this tremendous publication data set only to the data that I needed for my question. And I wrote a small software with the help of AI that, so to say, formalized what I did when I presented the first version of this research in the NetSci conference last year. So this should be reproducible, but it's so to say in active development still. The idea is you do like you download everything from OpenAlex, which you're allowed to do because it's open, it's really open. You transform it to a local index, and then you use that index for your analysis. By that you have, of course, the better speed and so on. So it allows to reproduce the research that you want to do. Okay, now coming to what I actually wanted to show you most, which is the two new methods that I came up with. Both of them emerged from this older research project on the history of the Max Planck Society, with the question being, is what classical historians found as specificities of the Max Planck Society in general, can we find that in the data sets? And one aspect was the idea that the Max Planck Society has established patterns of collaborations that are distinct, or that are showing fingerprints, so to say, of what the Max Planck Society is working with. And I try to explain to you what I mean by that. So the idea is, at that point, simply a query and the plotting. And keep in mind, so this project emerged as a collaboration of doing digital science as a kind of side quest for a very big classical historical research project. So what I needed was not like writing a software that someone would use, or doing like a statistical argument, but I needed convincing, understandable visualizations. And that is why my colleague Bernardo Boag at the time came up with this idea of, so to say, ego network plots of single institutions and their collaboration patterns in time. And what you see here is the Max Planck Institute for Extraterrestrial Physics between 2010 and 15. And every dot is one publication, but the outer layer of the ring is having one paper together. The next layer is two papers together, and so on. So closer to the source means a lot of collaborations. And then we can actually measure the average number of joint papers per institution. And you see here that it's very small, but they have a mean of 2.26. And I will tell you more about this in comparison to others. So we can, with these plots, look at either different institutions or the same institution in time. And in the case of the Max Planck Society, it's useful to distinguish between the different sections that I introduced in the beginning. So we have humanities section, in this case in blue, the chemical, physical, technical sections in the middle in red, and biological and medical section in green on the right. And at that point, it already looks a bit distinct. So we have, if you would look at the very small numbers, the partner institutions are very different. The number of joint papers are different. what is highlighted here is the structure, the internal collaboration structure in the Max Planck Society. So every other institute that is just a gray dot could be any institute worldwide. But at the time, we were interested in this internal collaboration structures in the whole society. If we look at one institute in time, in different time periods, we can say look at collaboration trends emerging. Here, again, the extraterrestrial physics has say, in average, increases the number of publications with one institution. If we compare this with the knowledge of the classical historical research, we can say a bit more. For example, you see here the molecular genetics MPI and extraterrestrial physics again. And while the Molecular Genetics Institute has more different institutes that it co-authors papers with, the mean number is very different. So, and the idea behind that, if you know a bit more about the research that is being done in this institute, is that in genetics they use like, for example, sequencers that are relatively inexpensive and can be easily shared. They don't have to be jointly financed. So they collaborate a lot in the case of genetics, but they don't have to, so to say, the return on investment is not so necessary. In the case of the extraterrestrial physics, we are talking about really big instruments that have to be built across decades sometimes. So from the point of instrumentation, it makes a lot of sense. The patterns that we see make a lot of sense. So this was very effective in talking with, for example, the general administration of the Max Planck Society to give them a picture of what we found. But if we want to talk about interdisciplinarity, it gets a bit more complex. The idea is instead of looking at single institutes and plotting it, we would like to be able to say something about contrastive measures of one institution against the background, the worldwide background in principle. And the proxy of interdisciplinarity that I use at this point is subfields, because I have to use open data, and OpenAlex is providing what they call subfields. At the time that I started this research, I was actually using fields of research, which is a classification that is used by Dimensions AI. But as I said earlier, I can't access that data anymore, so it doesn't make much sense to follow that line of research. But the idea is we create a network between subfields based on each paper that is tagged with a number of subfields. So we create a co-subfield network. And as I've written there's a lot of caveats to take into account with this type of analysis. So this are temporal, this field names. So it's an algorithm that puts the field name to a paper in 1960 for the same type of words used like in 1990. The algorithm tries to find these homogeneous structures. So the coverage has an influence on the algorithm. And of course, it's not so easy to take into account multilinguality without translations. But if we take this, let's say, grains of salt in mind, what structures are we able to see? And the idea is to look at the Max Planck Society and find a measure that tells us how different are subfields combined in the Max Planck Society, being aware of all the biases. And what we use here is called revealed interdisciplinary advantage. And that's the idea is so if you think about the network that is created by the papers between subfields, it's was written earlier, it's 252 different subfields. So what we actually have is a matrix of co-subfield occurrences. And by using this revealed interdisciplinary advantage, we take into account how often is this one certain subfield combined. Then we have a normalized matrix for the Max Planck Society and for the world. And we look at the differences. So how is this co-subfield matrix looking different for a certain point in time for the Max Planck Society? And we can furthermore test significance by simply looking, well, not simply, but by looking at chi-squared statistics. If we do that, so this is again written into a software package and again actively developed, so carefully in usage. But if we get these delta networks for in my case the Max Planck Society, and we find a positive entry, the interpretation would be that this specific combinations of subfields is uniquely more existing in the Max Planck Society than in the global background. And so that is interpreted as an interdisciplinary link. But we can also do the opposite and say if we find something that is negative in that measure, it's so to say a bridge between scientific fields that the Max Planck Society decided not to build. And if we look at this, that is the picture that I showed already last year in NetSci. I can compare this network between subfields with the sections, so the internal self-organized structure in the Max Planck Society, and try to pinpoint what are combinations of subfields that are driven by different, so to say, disciplinary organizations in the Max Planck Society. And it's interpretable, it makes sense. If I look at this with, so to say, my knowledge of the different disciplinary backgrounds, for example, this nodes of material science, molecular neuroscience, and cognitive psychology, for example, and experimental psychology. But at that point, I was not yet looking at the question if they are significant. And this is now coming to the really work in progress. The idea is that every combination of subfields is tested independently, so that is debatable, and I would be happy to get input on that in the discussion. But we do, for every of the subfield combinations, you can build such a contingency table, then calculate the chi-squared, and so to say what side of the statistics is favored. So is it more favoring global or more the organization, in this case the Max Planck Society? And if you do that for the different time periods, you can, so to say, dilute this networks. So you kick out all insignificant links, and the width of the edge is telling us, and it's very pronounced in 1964 to 1980 between organic chemistry and I think it's molecular biology. It tells us how much more likely this edge was in the context of the Max Planck Society. And this is now where let's say, I have to stop with kind of digital history and have to dive into the expert knowledge and bring this data to experts and saying, like, I find this edge, why? What is the interpretation? But I have found it quite interesting because even with my, so to say, relatively layman knowledge about the whole history of the Max Planck Society, I can say something about specialization in the sense of, if you look at this three time slices, three 15-year time slices, I can observe a specialization. So the Max Planck Society, in my interpretation now, is focusing on specific combinations of subfields of interdisciplinarity that emerged as successful and that became kind of a signature of the whole society. And this is what would be an interesting, so to say, research to be done in the future, hopefully. Another interpretation method with this type of network is something that I presented at the HNR in, I think, 23 or so. So can we look at these networks in time? So do we find clusters of significant co-subfield links extended in time? And what would they then be interpreted as? And if you do that, this is again work in progress. You find structures that are the dark blue line is physics and material sciences combined in the Max Planck Society throughout all times. You find molecular biology and neuroscience combined throughout times, but you see also things that could be interpreted as an effect of, for example, the German unification in roughly 1994, when new institutes were founded in the former GDR. And for example, also this what is there highlighted as archaeology and anthropology, that just coincides with the foundation of a new institute in Leipzig, where now I think 2 years ago the Nobel Prize went to. So again, it's a new method. It's not tested, but I would be really interested to now dive into this data with experts and look at, so say, at what points in time where which institute's significant, can we maybe find single persons that have driven this change and so on. Okay. Now, in the last, so just to recapture this general idea, so revealed interdisciplinary advantage actually comes from complex economy, and together with data networks, we can show how institutions diverge from the global norm. But I would be really, really interested for you to apply this approach to your institutions of interest, if it is interpretable. And what I've not shown you today is the negative data. So what is actually the missing interdisciplinary bridges of the Max Planck Society? Can we also interpret them? Are there conscious decisions behind that we can actually trace in archival sources? And one thing that could be traced is, for example, the decision not to go into medical research because it was considered too applied in the 1970s. Yes, and another important aspect is, of course, the classification of temporal errors, and then we would need to, so to say, go one step into more detailed statistics in the sense of full regression theory. So can we find regression in line with certain journals or temporal? That is, again, ongoing research, and I'm hoping I can make it part of what I will present now in the last 1-2 minutes. And if you want to hear more about this, I can just recommend to come to Turing. Okay, now, ongoing research, briefly. I'm currently working together with Roberto Lali in actually Turin, in the Politecnico di Torino, on a project that he has worked on already for like 2 years. The idea is now moving from pure history of science to what is called science diplomacy. So science being used as a diplomatic vehicle. And what we have there is a project on the fusion research and its effect on bringing Europe together. And in the project that they have run, so Fuse Europe, European Cooperation in Nuclear Fusion Research from History to Future Policy Design, they collected a lot of rich data sets, but have not yet looked at it from the perspective of historical network research in detail. And I will just give you a brief idea of what we have. The idea is of this joint collaboration with Roberto Lali is to look at the, so to say, aspect of social linking in commissions on publication output and the mental models, so the used semantics. And what the network that you see here is a social network, purely social, co-commission network. So we have like 800 main actors in that time period, in CERN, in the fusion program, in some smaller workshops. And it's the interesting thing of this data set is that it's not only scientists, classical people that we find in papers, but also kind of political or science organizers. And it's challenging to identify them in the publication record because they have no ORCID and so on. And we tried a bit with LLMs and so on, but it's not really helpful at the point. That's one thing I wanted to say. The other thing is we, with my colleague Raphael Schleitmann, he has developed a software package to query the NASA ADS research database and this allows me now to look at better, let's say, publication records in relation to the fusion research and certain journal papers. And we can look at this. This is actually an interactive visualization, so you can dive into certain paper clusters, topic clusters based on the title or abstract, and get an understanding of how good, say, the basis is that you want to use for your semantics. And as I've already hinted at, we now have to take very much into account the biases that we have due to possibly faulty metadata, because we are interested in this policy aspect. So we need to have very good information about affiliation. So where do people actually have worked? What places that have they acknowledged? And this ambiguation is a really big issue. And that's why we now want to look at this logistic regression and get an understanding of how certain journals have, for example, in average less good affiliation data, for example. Okay. In coming to the conclusion, so I try to show you that we are on, so to say, ongoing working on the moving social epistemic networks from a purely theoretical concept to actually an application. It's ongoing. I hope I was able to show you that OpenAlex can be used for reproducible science, but we have to, of course, take into account all of the biases that we get into our analysis by using such sources. On the macro level, we can find really interesting connections and that are useful to collaborate with experts, but we, of course, need to always get into this conversations with them. I've not yet looked at the micro level because it would be really interesting to get the statistics and so to say the meaningful, the significant effects of, for example, funding instruments. That would be really interesting. And I would be very much interested in getting your feedback on how these methods work for your institutions that you're looking at. And if you want to hear more about this, you can either come to the conference in Edinburgh on the History of Science conference, where we'll talk about the language analysis, or come to HNR in Turin, and I will talk more about the History of Fusion project. Okay. Lastly, science is a team effort, so I want to thank all of these people who have worked in the past with me, or still knowledge funding by the Ministry for Education and Research, and also the Max Planck Society and the Max Planck Institute for Physics, for History of Science. And with this, I thank you for your attention.